This video will discuss about queues. In this lesson, we have to learn about queues, examine various queue operations, learn how to implement a queue as an array, and a queue as a linked list. So these are the two implementations of queues. You can use array and as a linked list. And the other type of queue is priority queue. By definition, queue is a data structure in which the elements are added at one end, called the rear, and deleted from the other end, called the first. Now, if you want to add a new item to the list using queue, so the new item to be added will be put at the end. And the item to be deleted or to be removed from the queue is from the beginning or from the first. So this is called the FIFO data structure, wherein the first in, first out basis will be used for queues. The same as you are falling in line in the cashier to pay for something. And there are basic operations like initialize queue, is empty queue, is full queue. For the initialize queue, this method will be used to initialize the queue to an empty state. Of course, before you are going to enqueue and dequeue the list or the elements to the list, we need to initialize first our list. And initially it is empty. So nothing or no elements inside the list or inside the queue. This empty queue operation determines whether the queue is empty. If the queue is empty, it returns the value true, otherwise it returns the value false. This is very important since you cannot remove, for example, an item from an empty queue. So for that, you can generate a queue underflow. Another operation is full queue. So this operation determines whether the queue is full. If the queue is full, it returns the value true. Otherwise, it returns the value false. This is very necessary for the operation like in queue. So you cannot add a new element to a full queue. Otherwise, you can encounter a queue overflow exception. The front operation and the back operations are very necessary to return the first element and the last element respectively. But before displaying the first element or the front element and the last element, the queue must exist. The add queue and in queue, these are the operations to populate or add a new element to the queue and remove the element from the queue. Add queue is adding a new element to the rear of the queue. Rear meaning at the end of the list. Therefore, for this operation, you have to check that the queue must exist and must not be full. For delete queue, this is removing the front element of the queue. But before removing an element from the queue, which is to be done at the beginning or at the head of the queue or at the head of the list, the queue must exist and must not be empty because you cannot remove from an empty queue. Okay, what item to be removed if your list is empty? So for that, you can encounter a queue underflow exception. Now adding an element to a full queue and removing an element from an empty queue generates errors and exceptions called the queue underflow and the queue overflow exception. For adding an element to a full queue generates errors, that is queue overflow exception, while removing an element from an empty queue generates an errors and exceptions called queue underflow exception. And these exceptions are designed to handle these exceptions. Now, for implementing queue as an array, of course, we need to initialize the queue to an empty state. And let the queue front and queue rear point directly to the first and last element of queue. We need the following to implement the queue as an array. Of course, the array list, the variables queue front and queue rear. These variables will be need to keep track of the first and last elements of the queue. And the variable max queue size will be used to specify the maximum size of the queue. This will keep track on the elements, on the number of elements that is already in the queue. And we have here the figures of queue after the first add queue and the second add queue operation. Okay. At first, since the first element that is added in the queue is A, therefore the variables queue front and queue rear are 0 since the new element is being added at the first index, which is at index 0. And now, after adding two more items, okay, after A, so we have the B and C, in which populating or adding the B and C elements to our queue as an array, it will add this to the end of the queue. So B will be added after A and C will be added after B. And the queue front is still pointing to 0 since this is your front, okay, I mean the front element. The first element of the list is A and its location is at index 0. And the queue rear is 2 since the last element is located at index 2. Now, if ever you have applied the dequeue, some author used the delete queue or removing an item from the list as dequeue. That is the shorthand term for delete queue, so dequeue. So after deleting or the dequeue operation or the delete queue operation, the queue front is pointing to 1. That is, index 0 is empty and the front is now pointing to 1. So it's pointing to index 1. And still the queue rear is pointing to at index 2. Now there is a circular queue. Circular queue will be used to refer to a problem if a sequence of operations eventually sets index queue rear to point to the last position. So it will enable the elements to point to make it circular. Okay, that the last, I mean the courier point to the last array position. And this gives the impression that the queue is full. However, the queue has only 2 or 3 elements and front of array is empty. Okay, just like this one, the last element, which is at index 99, is pointing to the first element, which is an index 0. And it makes the queue full. And we have here a figure with the queue with 2 elements at positions 98 and 99, in which supposedly you have applied the dequeue operations several times until the the elements remaining are only 2, 98 and 99. And queue front is pointed to the element that is located at index 98 and queue rear is at index 99. And after one more add queue operation, since the available index or the available cell in this list is index 0, so the new item to be added will be put at index 0. That is, the queue front is 98 and queue rear is 0. Okay, so queue front is 98 and the queue rear is 0. And this is an example of a circular queue. Now, what's the difference between full queue and empty queue? This will be applied to a problem distinguishing between an empty and a full queue. We have the figures 7-9 and 7-11 have the identical values for queue front and queue rear. The possible solution for that is to keep account on the number of elements that are already in the list and let the queue front indicate index of array position preceding first element of a queue rather than index of actual first element itself. Now we need to create constructors to initialize our queue. For creating an array, we need to initialize it using the constructor. And the default value is 100. And for using the constructor, this will initialize queue front and queue rear to indicate that the queue is empty. You can know that queue is empty if queue front is null. And queue is full if only if we run out of memory. Meaning you don't have the space to add a new element. Okay, so as mentioned earlier, add queue or in queue adds a new element to the end of the queue, meaning to the rear. And this will be used to access the reference variable queue rear to implement add queue. The front, back, and delete queue. If queue is non-empty, then you can return the front, back element, and you can perform the delete queue operation. And if queue is empty, the method front terminates the program and the method back terminates the program, since the queue is empty. For the priority queue, the first in, first out rules in queue basically is or are relaxed. So we cannot perform the FIFO rules for the priority queue. Same as you are falling in line in a cashier, waiting for the um, salesman or waiting to be entertained. And here comes a senior citizen, so that needs to be prioritized, something like that. This will be used, the priority queue, for customers or jobs with higher priority or pushed to front of queue. You can use the ordinary list or linked list, which keeps the items in order from the highest to the lowest priority. And this will be used using a tree light structure according to priority. So the jobs or the customers with higher priority will be put to front. Thank you.